Hey everybody, I'm Zack Kass, Global AI Advisor, former head of go-to-market at OpenAI, and I am really excited today to be joined by Anush Elangovan. We're going to be talking all things AI, but particularly open source and the work that Anush is doing at AMD to electrify this category right now. Anush, thanks for being with me.
Thank you for having me, Zach. Super excited.
Before we do anything, let's just rapid fire. Favorite development from the week on AI? What's the most interesting thing that happened over the last 7 days in your opinion?
Oh, what I did actually was I made a ROCm port of onto a Mac system, which is crazy. It wouldn't have been possible about 6 months ago, but now we have a port of ROCm running on Mac OS.
A Mac Studio? What's the device?
No, it's an eGPU connected to an M5. So you can actually just get a Radeon 9700 and do all of your AI on it. The other thing was also we had a good Ryzen Max Strix Halo box, and I was testing it, and it's just amazing to use for local AI. All of the open source models running locally, including voice transcription, etc.
For the sake of everyone listening and tuning in, I'm sure they know who you are and they've seen this before, but could you tell us a little bit about what you work on and maybe what you're excited about why you're here right now?
I work on software at AMD. I'm super excited about AMD's philosophy of software. AMD has traditionally made very, very good hardware, like a pervasive, like CPUs, GPUs, NPUs, FPGAs. But the software had always grown, like, organically, like a board support package kind of like, it enables the hardware. But over the past 2-3 years, we've really leaned into our software methodologies and just like how do we build and ship software like a software company. That flywheel has started to gather steam, and we are seeing the benefits of that. And all of that is like underpinned with like an open source philosophy, which allows us to have open documentation, open ISA specs, open code, and that in turn is like fed into like frontier models that are really, really good on AMD hardware, because all of that is open source, right? And so now Cloud Code and Codex and all of these can really, really program to AMD's hardware really well. And so we are getting an AI-assisted boost that allows us to run much, much faster with AMD software.
Does hardware have an attention is all you need moment? Or maybe even better put it, what's the next one coming? What's the major, I actually don't know how to answer this. What's the major breakthrough in the last few years in hardware or software that powers hardware?
On the hardware side, we are seeing specific use cases kind of get large enough that we want to have a dedicated silicon footprint, right? Like, for example, we have low power devices that are doing like 100 tops. It's personal AI. There's like fast mode of inference that you want. So that's starting to get large enough where we're seeing custom innovation happen to address those markets. From a software standpoint, software is now just tokens, right? Tokens and time. So I just say software is tokens and time. There's nothing else. Software literally is just like someone who knows how to apply the tokens, and you have software. But you still need to have good understanding of what to build and how to build it, but the actual building is automatic. And so super excited about that part of it. And then there's the co-design part of now that software is plenty, we want to make sure it's, it can enable designing systems that are, that work in harmony very fast. And so we have 2-3 generations out, we're already building tightly co-designed systems. And I'm super excited about what that is going to look like in a few years when these things come to market.
Are you betting on breakthroughs, or are breakthroughs just new, found money and windfall?
I think the way I look at it is we need to plan for change and for breakthroughs to happen along the way. We don't have to necessarily bet on it, but you have to bet on you being able to adapt to change, and which is why I keep saying speed is the moat. It is literally the only thing that you can count on as to how fast you adapt to change. And so if there's a breakthrough, if it happens like today, you should be ready tomorrow to build it, ship it into your product.
If you could wave a magic wand for any single breakthrough that seems on a research basis conceivable or possible, what would change your life the most?
I think agentic AI, even from December to now, has changed it in a way that I'm staying up to like 2 a.m., 3 a.m., keeping my agents fed. And I will tell you, it was all agentic, because it's like you're about to get to bed and there's like, oh, this thing just finished this work, and you have to like tell it to do something. And it's done the grunt work, and now it's like really exciting, intelligent work that you have always wanted to do. And you're like, oh, I'm at the cusp of like getting this done. And how could I go to sleep now? I just need to like feed that agent, and then that agent just, and then another agent pops up and like, oh, I just did that for you. I'm like, okay, guys, I just need to like literally unplug and go get a few hours. Agents and AI that is reasoning and thinking, awesome, but we need agents that can understand now, right? That's the next frontier. And that just like distilled all of it down. Like, I just need to be like, okay, now I know this, and I want to navigate to this, or apply some level of like intuition from what I already have learned in the last 20 years. And that is what I think is the next frontier.
Of the wands you could wave that would materially change your working life, so your time, the work you're working on AMD, what are you hoping for? What are you betting on?
We're betting on AI big time, right? ROCm definitely powers a lot of like the top labs and deployments, but now that in turn is being used to rewrite ROCm itself, right? Which is like it's a little meta point, right? Which is like, hey, we're gonna try and get ROCm to be good, and some of my agents are like writing a Slurm replacement or other advanced things that just 6 months ago would have been like, oh, that's a 2-year project that we cannot do. Like a Windows driver that does this plus this is like, yeah, it's like 99th problem for me, and I don't know if I can put people on it, but I can definitely put agents on it.
One of the questions that a lot of engineering leaders are asking now, especially as we start to see AI move from application into infrastructure, is how do I build forward compatible solutions? How do I make sure that I'm not building a solution that's going to be redundant or just look bad in 6 months or a year? One, are you hearing that? I'm sure you are. But two, and more importantly, what are you saying to these people? What's the guidance you're giving product and engineering leaders as they try to build forward compatible solutions?
My guidance to my team is software is ephemeral. Software, you are building, if it passes and does something, ship it to production. Don't expect, like, it's not 20 years ago, I'm maintaining glibc and I need to make sure that this runs on the. All what you've created are transient tokens for the current generation of models, right? And so the next generation of models will be like, oh, I know what you did here. Great. I'm going to rewrite all of this in Rust. Like, for example, one of the projects that I did is called Spur, which is the AI native job scheduler. And I didn't know anything about Rust. And I picked Rust just because I didn't know anything about Rust. And I've not opened an editor. And it's all through Claude and Codex. And my tests pass, my harnesses is like 10 times more than what like Slurm has for its tests. And if something fails, I add another test. And then I go fix the issue. And so to your question on forward compatibility, again, it is like electricity. You take it, you use it now. There'll be more electricity tomorrow. You should just use the electricity tomorrow and do what you have to do.
If all software is ephemeral, and which I'm willing to buy, and you can make the argument that almost everything except steel and concrete is ephemeral when you're building things. When you're talking to engineering leaders and you're giving them advice on how to design their teams or how to build, what are the things that they should do in order to improve the quality and value even of the ephemerality of their products?
The leaders should just look at what is the outcome that you're going for, and everything else, since like the traditional hierarchies were built in the Roman times, right? It's like there's a squad, there's this, because there's information flow. There's a hierarchy of like, okay, how do we control this information flow and bring it? But now this is the great equalizer, right? It's like everyone's wingspan is like, you've kind of like dissolved a hierarchical infantry to build SEAL teams of like 200 SEAL teams. That's what you've gotten, right? Like that's the way we should think about it. So you literally have, a fully contained unit that can work autonomously and go do a mission and come back. And so the next level up is already someone who's operating at a entire like outcome, right? Like they're like, okay, you're doing this. It's very strategic. It is not, you're not paper pushing to move the ball forward like 2 feet, 4 feet. you are orchestrating a entire like deployment of whatever you want to go for the outcome.
For engineering leaders who fine, engineering product leaders, they can build the right teams, they can design the right orgs. Then the next concern is how do we pick the right model? And there's this increasing sort of tug of war between trying to find the right model, but also wanting to avoid vendor lock-in. What's your advice there?
Yeah, I think I'll just start with vendor lock-in, right? Like our whole philosophy, and I think I mentioned this yesterday at the AMD Dev Day. Open is not just a license choice for us. It is a philosophy. It is a philosophy that we want to bring everyone together. We want to bring, it should be for the collective intelligence to improve and to raise all boats, right? And that is only done with a open ecosystem and an open source policy. So we subscribe to that, and that's the reason why I'm at AMD doing what I'm doing, right? It raises all boats. Whether it is actually like the models and how we adapt to what models, I think that is increasingly like a choice, which is great. We should have that choice, and it will be a choice of like the initial spike will be people will have to experience magic, right? They'll be like, wow, I just created a PowerPoint and it took no time, right? So for the magic, you want them to experience the magic, right? Like you want people to be like, okay, I will do this. Then over time, you're like, okay, do I need to use, whatever expensive thinking tokens, or do I need to use the little bit more like, okay, I can manage this? Because if we ask them to start managing it before they are sold, that'll be the reason why they're not sold.
How does one of what first determine what model they should use for any given task, and how do they make sure that they are creating an ecosystem or an application that allows them to route to the optimal model for that task?
Again, I'll go back to my electricity analogy. We've just discovered electricity now, right? And there's like 50 hertz competition, 60 hertz competition, there's 110 volt competition, there's 220 volt competition. There's like, should the plug be this way? It will all normalize over time. And yes, I'd love to have a generator and a power wall, but in the end, it's electricity. We will get electricity, and then with electricity, what will we do? We're going to build electric cars, we're going to have motors, we're going to have this. So as much as we are super excited about like, oh, is this coming from a hydroelectric plant, or is it coming from a thermal thing? And it's like, it's this much or that much. In the end, what we should look at is that we have just like found electricity, right? And so now what will we do with electricity is the bigger question, and how will it touch people's lives? And we need to focus on that aspect. It's very important, really. I mean, but in the end, it's going to come down to what is the intent and outcome with electricity? Like, what do you want to do with that?
Now, two questions. One, if you had to pick a model in the future, what model do you think we will consider the point of diminishing model returns? How far away are we? And maybe you could pick a model family. I'm open to it. And also, when we arrive at that place, how do you think most developers, programmers, will route their application to a model? What do you think that model universe looks like?
The model routing and security of that too. So there's the cost-based routing, there's the privacy-based routing. All of that is super important. And at AMD, we are building, client laptops that, are immensely popular. So we're working to build, agent sandboxes that are like really lightweight. Like it's like your Chrome sandbox. You're running Chrome. It has an inbuilt sandbox. It's running at like maximum performance. You don't feel like it's running in Docker. Imagine you have to run Chrome in Docker. You're like, okay, what does this mean, right? That's where agents are today. It's like, yeah, run it in OpenShell. And I was like, okay, so it's spinning up a Docker instance. And so we're thinking of it as like fine-grained process level, landlock, bubble wrap, all of that stuff, right? It's like fully scoped for agents to operate in, and then humans to interact with, like the ability to expose what you need into those agents. And so that's a important part. And then you add the routing part of it, which is like, hey, I can run my voice transcription on my NPU, so I can run that in real time, which is great. I can run a large model on my Strix Halo box, like a 100 or 200 billion parameter model. But then when I need deep thinking or deep reasoning, I can hit Opus or GPT in the back end, right? So that will increasingly become part of your like automatic routing, automatic securing, and there's like a lot of innovation to be done in that space. But all that innovation you should just keep in mind is if it's software, it's just tokens and time. Don't forget that, right? It's like you can't be like, oh, I saw this, and I'm going to start a startup that's going to do agent security for this, right? Just coming back to the ability to like secure these things is important, but it's also it'll move fast. You just have to do it, and it'll become part of our regular flow.
The world right now is embedding an economy around the GPU. One of my takes in the book, and one of my consistent takes, so I'm not saying this just to be a sycophant, but I have said this for quite some time, is that the threat to the GPU is not actually that we won't need more compute. That's a bad take. We're going to need a lot more compute. The threat to the GPU might actually be a major breakthrough in inference, how we do it, but also the CPU. Let's talk about that.
From an AMD standpoint, right? AMD has made a multi-generational bet on, not just CPUs, like we have the entire portfolio of like CPUs, GPUs, NPUs, FPGAs, embedded products. And all of these have an AI touch point. And like, embedded and physical AI, right? Like we have robots that are like autonomously being updated with world models to navigate that, right? But then on the data center side, we have, instinct. But I think CPUs are underrated, but I think recently people have been, like awakened to like, oh, all tool calling happens on the CPU. Like, welcome to AMD's like, bread and butter, right? CPU. But what we want to also do, and what we haven't yet fully unlocked, and we have like aggressive plans to unlock, is to make all of these accelerators look seamless to your application, so that you can consume an AI cycle on a CPU, you can consume an AI cycle on a GPU, you can consume an AI cycle on an NPU with like zero cost transfers, right? And so that allows you to like just say, I have my Strix Halo laptop over here, and this Strix Halo laptop can consume like every top that's available on this. I will be able to like run between the CPU, GPU, and NPU.
If you had to bet, what percentage of inference in 3 years is going to be done on the CPU versus the GPU?
The way I would bet is your CPU and GPU will be fully consumed by AI.
Right. And so then the question is, will there be more CPUs or GPUs on Earth?
That's a good question. Whatever you buy, make sure you buy an AMD one. That's all I can say.
This household runs on AMD.
That's great.
How'd you get into software engineering? Where'd you grow up?
I grew up in India. I grew up in a town called Ooty. They had a British boarding school, so I went to a boarding school from when I was 3.5 or 4 until I was like 17.
When did you get into software development?
So when I was 10, they had the first software engineering class in my boarding school, and I took that, and there was some block diagram of input, output, something, right? So, but when I was like 12 or something, I made a little rubber stamp with my name, and it said hardware engineer, not software engineer. And so my parents were like, "What hardware engineer? You're going to sell like pipes and things?" They were like, "Whoa." So they thought like real hardware, which is funny. But that was when I was in my 7th grade. So early, and then I did a lot of graphics when I was like 13, 14. Back with BASIC and CGA monitors that had 3 colors, and you had to plot lines. Back in the day.
Am I understanding this correctly? Your foray into hardware engineering started really early. Is that right?
Yes.
Wow.
I mean, but for a long time I was a software engineer. I think I'd like to classify myself still as a software engineer, but at the time I was just fascinated by hardware. But you couldn't really build anything, right? We had like 2 8086 processors. And the best thing you could do is like write TSR programs that terminated in state resident. So people would like, oh, press F11 and it did something, and they were like, that's not in the book. What do you mean you have a TSR that could like so even the admin was like, what did you do there? Because you could peek and poke memory, and like BASIC literally had like a peek this memory, poke this memory, and you could hide things in, which is fun exploration.
How did your background in compilers and open tooling influence your approach to ROCm?
around 2000 or something, 2001, I think, there was a Linux distribution called Gentoo. I don't know if you know it, but I really like to build with Gentoo because it had the entire, like, you'll have to build everything from the file. You'll have to compile the compiler before you start building anything. Then you'll have to build the file system. You'll know everything. And I was just coming out of my, I think, PDP-11 operating system internals class in my master's, and I was like, that looks good. And the next best thing was like, let me do this on Linux. And so I started with Gentoo. And so even my laptop here runs Gentoo now, which is, it's, it's a, it just, if someone says they run Gentoo, that means one, they know the system, two, they have a high tolerance of pain. And too much time that they put into computers.
Do you remember like connecting with Gen 2 where you were like this, like you saw it for the first time and could not unsee it?
I think it was just like late night hacking, and I was like, oh, Red Hat and Ubuntu and SUSE and da-da-da, and it was just like, but then when I built it, I had like the most performant rig that could run, I think, some games or something at the time. And my friends were like, wait, why is yours running so fast while we have all of this Ubuntu or Debian, and it's, we have, because they couldn't go below the stack, right? And so for me, it was coming bottoms up, and that I think still helps even in the AI world, right? Like that curiosity of like building with first principles up is what increasingly you will have to do, but just that now the rote part of it like will just be done by agents, and you don't have to sit and like babysit it. You can actually now build a full distribution. In fact, I was talking to DHH. I was going to send a Strix Halo to him because George had tagged him on Twitter or something. But I saw Omarkey, and I was like, okay, now you know what, I need to get Omarkey running on Gentoo instead of Arch, which is what it's based on. So that's another side project. Sorry, that definitely is not a work work project.
You have said multiple times on this call, or you've alluded to this idea of software is software is ephemeral. Maybe everything is too, by the way. And but you've also said in the past that software should just work. Where is ROCm on that journey? How does ROCm just work? And also, is ROCm a stop in AMD's journey, or is it a permanent solution to an ephemeral problem?
On the journey, I think we are there. We are shipping like a software company. The next phase is like making sure all of the surface area is exposed agentically. So as much as we would want documentation for humans and documentation for DSLs and humans in the loop, we want machine accessible stuff, right? If you go look at like AMD's ISA specification, you go to amdgpuopen.com. Every architecture that we released, we have a PDF for humans, and we have a machine readable ISA that was already released. This is before the agent hype, right? So when I first tried to do a virtual GPU, the first thing that my agent did was like downloading the machine readable ISA. I was like, oh, I didn't even know there was a machine readable ISA, and it parsed it, it did everything, it got all of the ISAs, it knew exactly what the cycles are, etc. And then it just built it just from that one thing. So that's the level of like commitment we have to build in. And then, software, AMD's history had been checkered in terms of like software, right? And so that's a lagging indicator in terms of, perception, and that's okay, that's fine. So usually what I do and our team does is, if there's an issue, let us know the issue, we will grind it down. If there's an opinion, we hope you will change your opinion once you see the issues are fixed, right? So that gives you the like baseline of what it is. But then going forward, my view is ROCm is ephemeral, right? Like it is a platform. We will commit to like making sure you can build on this for the next 10 years. But I may rewrite the whole thing in Rust tomorrow morning, right? Like I'm not tied to a...
I would not put that past you based on everything I've learned.
I will consume a few more billion tokens, but that is how we want to look at it. You don't, and I think you made a meta point in there that everything in life is ephemeral. I kind of subscribe to that too, but while we are here, what we have, we should just be able to like build and move on it fast, because there is no permanence in like, okay, this code base I'm going to maintain for the next 20 years, right? Yes, we want to build with that mindset, but the execution should be that, okay, tomorrow morning it may change.
Finish this sentence. In 5 years, I hope that ROCm is known for blank, which it is not known for today.
In 5 years, I hope that ROCm is seamless, transparent, and it just works. It's what you build on for open AI, and open models and everything that you want for AI, but it's just transparent. It should just be like your Chrome browser, for example, right? You don't know what version you're using. You don't care what version you're using because it just works. It's tested. It works. It's just like I open my browser and it works. Snap, right? So we want to make ROCm like that, and it works across multiple platforms, multiple operating systems, and you just target that surface area, and you just assume it works.
What is the key unlock for you in achieving that?
AI agents and AI, right? Like and the team is super motivated. So when I talk to the team, I just tell them, hey, I mean, we operate like a startup, and now it's a startup with 10x the power, right? The part would be, how do we bring people along for this journey so that everyone gets on the bullet train, right? And not just have to walk to the destination.
And for those who are, okay, so people are excited for that in 5 years. For those who have either written off ROCm or you're calling on them to reassess ROCm, what do you want to say to those people?
I will ask everyone to reassess it with truth on the ground, right? Like, because there's always like an opinion on that may have been formed. Like it's a journey, and sometimes you have to have a Windows 98 and a Windows Me and a Windows 7, and then when you get to Windows 10 and 11, it's seamless, right? Like I'm sure the people that were complaining about whatever issues happened in the past, it is like a robust operating system now. So similarly, I think ROCm's gone through that transition and transformation. But if there are specific issues, just file a GitHub issue, tag me on X. It will get taken care of.
I know that you will respond to them. I wonder when you sleep, now that I know how much time you spend on agents, because I see how much time you spend in the community. So
yes, I try to get some sleep. Human after all, not agent.
all right, Anush, we've captured some questions from developers. I'm going to read them out to you and give the community a chance to be heard. All right, Anush, Deepak asked, what does a developer's first hour with ROCm look like 2 years from now, as opposed to the experience we know today?
That's a very good question, Zach. And I think increasingly the experience is going to be fully agentic. We already have like a TUI interface that I'm prototyping, that our team has been playing around with. So it's going to be more human language centric, even to like install, upgrade. You'll be intent driven to say, serve the latest language model, right? That fits in my system. So you'll figure out what fits in your system, how do you download it, where do you download it from. All of that is like stuff that will be automated for you. And so expect that to be the interface from to ROCm.
Fractal 2042 asked, as AI demand rises, lots of people are starting to worry that frontier AI will become inaccessible to individuals as the current subsidized price fades. How does AMD plan to bring inference prices down so individuals can keep accessing the world's best AI models?
Yeah, that's a very good question, Zach. And this goes back to what you had asked too, and we had talked about earlier, right? So
you didn't get an answer to that earlier, by the way, Anush. So I'm very excited for you to.
Yeah, so I think the there's the infrastructure piece and the hardware piece, right? Like we increasingly are going to be focused on getting as much compute power into the hands of developers and users, so that frontier class models run seamlessly on your local hardware without any access to the internet or the cloud, right? And as we are seeing even today, like using the Quen coder models or Kimi K2s and GLM too, right? On a local setup, you are increasingly getting like frontier class access locally. So I expect that to asymptotically like get to a point where it'll cross over the intelligence threshold, and you'd be like, yeah, I'd just use what's on my local AI box, and then we will continue to like work with the backend also, right? So that the idea is that even frontier class models that are in frontier labs get increasingly cost efficient. So there will be a time dilation in terms of like when that intelligence flows to a local system, but it will happen.
Okay, I'm gonna press you because you know what I'm gonna ask. What year and what model class are we going to stop worrying about having access to the frontier?
If you have seen my messaging on speed is the moat and change is the only constant, I do not like absolutes in terms of like when this will happen, like a prediction that 2028 this is going to happen, but we should be prepared for it to happen fast, and I think in the order of a few years, 3 months we've seen 3 months or 5 months back. I was not a subscriber to anything agentic. I thought agents were like prompts in a cron job, right? That was my understanding of agents. So that's just 5 months ago. So I think give it a couple years, and the intelligence would be so far up that you wouldn't make a difference. It wouldn't matter where it's running, but you'll still have like some stratification of like what the class of models are.
All right, Curved asked, NPU has seen limited adoption. What do you think happens to its future?
Yeah, very good question. I think NPUs are focused on very power efficient model delivery. I think there's going to be a class of models that is best suited for NPUs. In fact, I have a prototype of like a push to talk with codecs that works on the Strix Halo NPU, and this provides for like very fast speech to text and text to speech that is perfect for the NPU, right? So there will be a class of models that just work beautifully, and you want like 10 hours of battery life running that on an NPU. So it's got the ability to like get that, but it always has the trade-off between programmability and the efficiency gains. And so it's got a little bit of a step function, and that's where some of the compiler research and compiler work that's coming in will help. But also some of our runtime changes that allow us to go between CPU, GPU, and NPU seamlessly provide us the ability to fall back to GPUs for a while.
Finish the sentence. In 5 years, the computers will rank in the following importance.
Your local machines are going to be the first ones that you start using and you touch AI with. Second would be from local, it'll be straight up to the frontier class like backend, right? So the big clusters that can serve deep thinking models, and then there'll be things in between your like from your like phones and other classes. Does that answer the question?
It does. And then how do the processors rank accordingly?
Any processor that can do any AI cycle will be consumed.
Okay. It's a good, as good of a non-answer as I'm going to get from Anush on this one. The last question is exceptionally long, and so I'm gonna post it, and I'm gonna try to truncate it as I ask it. But Happy Pie, good name, Happy Pie said, provide the context. As a developer using Strix Halo, I've reached a point where ROCm feels stable enough to invest in. Congratulations, Anush. However, RDNA 4 workstation cards are limited to 32 gigabytes, and there are no modern CDNA workstation options, which I would strongly prefer. Then Happy Pie goes on to ask, is there any possibility of a single CDNA workstation card or an RDNA 4 or 5.5, 5.5, 4.5 card with 120 gigabyte plus? Server solutions aren't practical as they're only available in multi-GPU configurations.
I will say, I hear you, and you will not be disappointed. How about that?
And in the rich tradition of smart Anush non-answers, it sounds like a pretty good answer. So last question, Anush. Curved asked, what do you think about Intel AMX? Has parity been discussed?
I think we definitely keep an eye on like all the kinds of like innovations that are happening on the GPU and CPU side. And again, we will have products that are very competitive and without pre-releasing anything, right? So we will make sure that the product remains competitive.
Anush, thank you so much. I had a blast. I like you a
Thank you,
lot.
Zach.
I learned a lot. I hope the developers did too. And I look forward to doing this again to revisit some of your predictions and some of mine.
Thank you, Zach.
Thanks, Anush.